So today we did some practice problems in class on 11.4 with the arc length, circumference, things like that. We just decided to have you guys do some more practice because we didn't really get too involved with it, okay? Very basic, kind of baby steps. So let's start with kind of just a quick recap type problem, and then we're going to take it a little bit further. Okay?
All right.
So this one, it says find the radius. Now, notice what I'm giving you. All right, let's kind of think about what we're trying to find. It says find the radius. Now the radius, I'm going to just label this R. That's what we're trying to find. That's the question mark. What does the 9.8 represent?
That's the length of the arc.
So this is the arc length. Okay, so I'm going to make a little side note here. And then what's this represent?
That would represent the measure of the arc.
Okay. So that's because it's actually a central angle, and we know central angles that associate with the arc have the same measure.
Right.
Right, so what we did was set up a proportion. We know that in general, remember, the arc length compared to the
Whole circumference
is equal to the
arc measure. And we know that degrees is always out of the 360.
out of the whole 360 degrees. Again, lengths, so units of inches, feet, compared to the degree amounts, okay? So, arc length, we know that is?
That's the 9.8. We don't know the whole circumference yet.
I'm just going to leave that as circumference. We'll talk about what we'll do with that in just a minute. Arc measure?
That's 125 out of the 360.
Now, notice this proportion actually is not helping you find the radius directly. It helps you find the circumference. But if you know the circumference, could we find the radius?
Definitely, because we know the formula for circumference of a circle.
So we'll talk about that in just a minute. Now, what are you doing at this point, Miss Oakgrave?
I'm thinking we could go ahead and cross multiply.
Okay.
And I know that when I take let's do 125C is equal to R, and that will end up being 3,528.
Now, another thing we've talked about is we could simplify this ratio. So you could simplify 125 to 360 and then go ahead and cross multiply. It's up to you. It's going to give you the same outcome. All right. So then when you go ahead and divide, you get a circumference of
28.224.
All right. Now, is that my answer?
No, that's the circumference, and they asked for the radius.
Now, what do we know about the circumference that involves the radius?
Well, I know a formula that if I take 2 pi r,
that gives
me the circumference.
All right, so we know the circumference. So essentially, we know that the circumference is 28.224, and that's going to get you the 2 pi r, right?
Right.
Now, we want the radius, so what am I going to do?
So we need to divide by 2 pi.
And what are we going to remember when we divide by 2 and pi?
To use parentheses around them.
Around the 2 and the pi.
Because there's more than one piece.
Yes. Or, we talked about this, divide by 2,
and then
push enter, divide by pi, push enter. Now, I think we're probably going to round.
We're going to have to round, yeah. And we'll take it to the hundredths place. So let's say 4.49.
And usually, guys, we'll tell you how to round, or there'll be units. We probably should have left the units on there so you could see that. But that would be the radius. Okay?
All right. Now, I have a question on this one. Instead of putting the C into the formula, could I have put the 2 pi r in place of C in the original equation?
I think we could do that, because that's what C is, right?
That's what C
So
is.
basically, what that would look like would be like this, and then we could still cross multiply.
Yeah, and then that way you're solving for R, and you're not having to set up two separate equations.
It's a more direct approach.
Two different ways to do it. And guys, we wouldn't care which one you did.
Yep. Okay, now we're going to take it a little bit further.
All right.
Okay, with some different types of problems.
Now, yesterday on your classwork, you noticed there were some things talking about revolution. So we've seen this vocabulary term before. We know it means a full rotation, basically a whole circumference. It says we've got tires from one different bike. We changed the problem.
Yeah,
sorry.
we did change
one
it.
Bike is shown. How many revolutions does this tire make while traveling 25 feet? That's funny. We tried to make it a little bit simpler for you guys and forgot to change the wording.
Forgot to edit. Oh, well.
Okay, so we have a tire from this bike, and it's shown, and it says, how many revolutions will that tire make while traveling 25 feet?
Okay, so what I'm thinking, because you made that comment, the one revolution is just one circumference. So if I could find out how long that tire would take, like if it completely made a complete revolution, that would be helpful. So let's find the circumference. Now, to find the circumference, I can use the 2 pi r formula, or I could use the pi times diameter.
Right.
Now, I'm looking at this, and like that 2 inches is like the width of the tire.
That's the actual, the tire itself.
And then like the 8 inches represents like one of the spokes of the, so if I add the 8 and the 2 together, that gives you a total of 10 for the radius.
Love it.
So I'm going to use the 2 pi r idea. So circumference equals 2 times pi times 10, which gets you 20 pi. Now, this is in inches. I want you to write that down.
Because we don't want to lose track of that either.
Yeah. Okay. And the reason why is I'm thinking what you said earlier. You said something about 25 feet.
Yes.
So careful with those units. Those are not the same units. So my thought is let's convert everything to the same units. So I think it's easier to convert the 25 feet all to inches.
Probably.
So to do that, you just do 25 times 12, and that gets you 300 inches.
So we want to know basically how long is it, or how many revolutions will happen in 25 inches.
Okay. So we know one revolution is the 20 pi. And if I want to do 300 inches, I'm just going to do 300 and divide it by the 20 pi. Now, I'm going to put parentheses around that 20 pi.
I was just going to say, we want to be careful because, again, if you just hit 300 divided by 20 pi, your calculator is going to divide
and then
the 300 and the 20 and then multiply your whole answer times pi. So be careful. Make sure you're as smart as your calculator.
So when you type that in, it's going to say 300 divided by parentheses 20 pi and then push enter. And it says, it's going to be a rounded answer. It says about 4.77 revolutions. Okay?
So we know that it's going to go around 4 whole times, but we're going to have really
not
almost
complete revolution.
a little over 3/4 of another revolution, not a whole revolution.
Yeah.
And that's okay to have a decimal answer unless they say how many entire revolutions would be made.
So it would only go 4 revolutions and then a little bit more.
Right.
All right. Now to something we haven't exposed you to yet, okay? It says find the perimeter of the shaded region. Now, here's the deal. I want you to think about what the shaded region is made up of.
Okay.
Right? Now, the shaded region, and we purposely did this because we wanted you to kind of get a visual of it. We left these little arcs on here because it kind of, in a sense, you're seeing a full circle. But the shaded region, and that includes even, maybe I picked the color that here. It even includes this. We put that there so you could kind of see. It's all of this. So basically, I'm hoping you're seeing a circle, and then you're also seeing what kind of shape inside of it.
In fact, it looks like a hexagon with just, instead of having 3 of the edges that are there, it looks like they just round them out.
So what makes up the actual shaded region? Well, the parts, like you said, parts of that hexagon, really, in a sense.
Well, the whole hexagon.
Well, because we're talking about just the perimeter. Okay, so we're talking about this is not the perimeter of it.
That's right. You're right. I see what you're saying.
So when we're talking about perimeter is basically the distance around that shape. Okay? So this is what a lot of times what I like to do. I like to kind of break it up. What makes up that perimeter? So you're seeing hopefully 1, 2, 3 segments. And those are easy to find the length of. Okay? So we have 3 segments. But what else makes up the perimeter of that shaded region?
Well, there's 3 curved pieces.
And what do we call those?
Those are
curves.
arcs.
They're arcs, yeah. So we have 1, 2, 3 different arcs. So if I can find the distance of those 3 segments, and I add on the distance of the 3 arc lengths, then I know the whole perimeter of that shaded region. Does that make sense?
Absolutely.
So a little bit of a game plan, okay?
And guys, we would advise you to think about that each time.
Yeah. Yes.
Because that really is helpful.
Yes. Let's start with the segments because that to me is the easiest.
Great.
Now, hopefully you're noticing that all of these have little tick marks, so they're saying all of these little segment pieces are the same.
It's a regular hexagon. And we know how to find the side length because that's really what we're finding of a regular hexagon.
Yeah. But even better, we know what the side length is because they give you that.
Hexagons are all going to be formed with equilateral triangles, so that the fact that they give you the radius there is 6, we know that's the same as all the side lengths. And they even mark it with a tick mark.
Yeah, you don't even have to think about it. So it's going to be 3 times 6. So we know the segment lengths, there's going to be a total of 18.
Love it.
So we know we're going to be adding that to whatever the arc lengths are. Okay. Now, let's think about the arc lengths. In order to find the length of an arc, now we can approach this a couple different ways. I'm going to kind of tell you one way, and then I'm going to push you in another direction, because sometimes it will work out nicely. To find the arc length, remember, you need to know
measure the central angle.
Measure the central angle, which is the arc measure. All right, if you kind of go back a slide, let me go back here. To find the arc length, you need to know the whole circumference, which we can find because we know the radius. We need to know the arc measure, which is the central angle over 360. Okay. So, well, wrong slide, sorry. Central angle, and I'm going to draw in another radius. How do you find the central angle?
We find it by taking 360 degrees divided by the number of sides, which was 6.
So that would be?
That would be 60.
Okay, so that would be the arc measure, all right? So if I was doing this, I would take the arc length, I don't know, so I'm just going to call this x. Arc length to the whole circumference, which is 2 pi r. What's the radius?
So that's, the radius is 6, so it's going to be 12 pi.
Equals?
Over our 60 over our 360.
Okay, so I'm going to go ahead and simplify here. She said 12 pi down here. And I'm going to even simplify this. I know 60 over 360 is 1/6.
Right.
This will allow me to kind of multiply a little bit quicker. So when I cross multiply,
I'm going to end up with 6x equals a 12 pi.
So x ends up being?
So if I take 12 pi and divide it by 6, I'm going to end up with 6.28 approximately.
Well, I'm going to leave it in terms
exact?
Of, yeah, because it doesn't have any,
exact for now.
It has no units.
That's true.
And it doesn't say
not even
rounding.
in there.
So I'm going to leave it as just 2 pi.
Love it.
Okay, so that's this arc length. But what's going to be true about this arc length and this arc length?
Well, they should all be the same.
Yes. So we have 3 of the same arc length. So we're just basically taking 3 times 2 pi, which is?
6 pi.
And can I combine 6 pi and 8?
No, they're not like terms.
So I'm just going to leave it as 18 plus 6 pi. Or you can rewrite it 6 pi plus 18. Now, again, it doesn't say anything about rounding.
It doesn't.
Okay, and it doesn't have units, so I'm just going to leave it like this because it's acceptable.
Now, if there had been units, then we would want to type 6 pi plus 18 into our calculator and get that like 36.8. Yeah. But we're not going to worry about that on this one because they did not give you units. It was supposed to just be
now,
exact.
I said there was another way you could find those arc lengths. Okay, we just found one of them, and since they're all the same, we just multiplied by 3. Seems easy enough, right?
Sure.
Here's the deal. We have 3 of arc lengths we're finding, right?
Right.
If you think about it, that hexagon divides that circle into how many arc lengths?
6.
6. And what's going to be true about all 6 of them?
They should all be the same.
All be the same. But we only want 3 of them. So if you only want 3 of them,
half of them,
that's half of them. So here's the deal. This was the circumference. Okay, if I simplify it down, the circumference of the whole entire circle, all the way around, is 12 pi. We only want half of them. So if I divide by 2, there's where I'm getting the 6 pi.
Ah, so we could almost, like, I could almost see in that picture, if I repositioned where those extra little arcs are and swapped them with some straight segments, I could take that little piece.
So it's like this, this, and that.
And then just make the bottom parts all straight because you're just swapping them. You're not really like changing the shape. Oh, okay.
So a kind of a word of advice, and I know Ms. Hokegrave would agree with this, is if you see that some of the arcs form like a full circle or half of a circle, it does require basically less work, okay? Because then you're just doing what of the whole circumference, okay? So don't make assumptions, all right? But this is one where we know for a fact that we only wanted 3 of the 6 congruent arcs, okay? Just an idea.
Okay, for this next one, it kind of looks like a C that we have here, and we're finding the perimeter of our shaded region. Now, let's talk about what makes up the shaded region here.
Okay, well, I don't see any segments this time.
I
just
no
see
segments.
Arcs, but I see semicircles.
I love it.
Which is half of the arc.
Yes.
And I see, let's see. Okay, I see like the 2 smaller ones kind of on the right.
These
Okay.
little bitty ones right here. And let me get a different color. Let me get some.
Yeah, so there's that 2 smaller ones, and those are going to be the same. So we have two small ones, okay? And we have kind of this medium-sized one, kind of curves in that way, the opposite
We
way.
have one medium-sized one.
Just only one. And we have kind of the same direction as that medium one, the larger semicircle. And there's only one of those too.
Okay.
So if I can find the lengths of all 4 of those semicircles, then I can add them together and you get the whole perimeter.
Love it. Now, one thing I want to point out, you said 2 small semicircles. What do two semicircles make?
If they're both congruent semicircles, which they are, they're going to make a full circle. So
Really?
really it's just one circle.
One small circle.
Yeah.
Okay. So I really need one small circle's circumference. I need half of a medium-sized circle circumference and 1/2 of the large circle's circumference. So it kind of helps, again, just to get a game plan. This is just going to help us to get that picture of where we're going to go.
Okay.
So let's go right in order. Let's start with the small semicircle that you talked about.
Okay, so it's one circle, and to find the circumference of a circle, you can do 2 pi r or pi times diameter. And since they give you the diameter of 8, I'm just going to say that is basically 8d. Or 8 pi.
8
sorry.
pi.
8d.
Yeah, D is the 8. Yeah.
Yes, 8 pi.
Love it. Because that right there, and I'm going to mark that this is the small again, is going to be that diameter times pi. So these two together form that whole circle of 8 pi.
Okay.
Love it. That's that one circumference right there. Now, let's move to the medium-sized circle.
Okay.
What do you know about the diameter, because they give us that as well, of the smaller, or the medium?
The medium one has a diameter of 16.
Okay, so the circumference would have
Be
been
16 pi, but I only want half of that. So that ends up being 18 pi, or 8 pi. So that is your medium-sized one.
and that's that half the circumference because we're doing the one semicircle. Okay, and then when we move to the large, we know that large circle, now they don't just flat out give us that
Okay, so what I'm
diameter.
thinking, okay, you're going to have to add up all of those. So 8, 16, and 8, that gives you a total of 32 is the diameter.
All right, so if I
Half
want to do
of that.
half of that larger circle circumference, so 32 pi divided by 2,
Gives you 16 pi,
and again, that's the large, sorry.
large one.
So we've got our 2 small put together already,
Uh-huh.
the 1 medium and the 1 large. So what am I going to do to get the whole perimeter?
Just add those together. So 8 pi plus 8 pi plus 16 pi.
Now, can we combine those?
Yes, because they all are in this terms of pi, so they're all like terms. So this would be 32 pi. And again, there's no units. There's no reason to type that in my calculator. So I'm just going to leave it as 32 pi.
Love it. Okay. So again, getting that game plan before you get started can really help you guys out too.
All right, last one. All right, it says find the perimeter of the region. Okay, so this is again another perimeter of shaded region. So let's kind of get a game plan of this to see what makes up this shape. Okay, can we do that?
I think that sounds great.
All right, so what kind of things do you see that makes up this kind of the shaded region?
I see 4 segments.
All right, so are all the segments all the same?
They're not all the same.
But they do give you the measure of all 4 of them.
Love
Now, are these segments of that
No,
region?
those are the radius of the circle, which is going to help
Kind
me
of
with
help
my
us.
arc length.
Okay,
but yeah.
so I think that can be confusion. A lot of times people think that 2 and 2, these are segments. Yes, they are technically, but they're not part of the perimeter of that shaded region.
Right.
Okay, so we have four segments. Okay, now they're not all the same. But I'm just going to make a little note. We have 4 segments, and they're not all the same. We'll talk about that in just a minute. And I also have
I have 4 arc lengths as well. And as I look at those are all going to be the same.
and I'm just going to go ahead and put 4 congruent arc lengths.
Love that too. And we know that they're going to be congruent because we see that 150 degrees, which actually is the measure that's outside of the arc that we're
Okay.
not seeing. And they all have that radius of 2.
Okay, let's start with the segments, mainly because those are the easier of the pieces. All right, so I'm noticing, okay, I have a 3, a 3, a 5, and a 5. So basically I have 2 3s and 2 5s in a sense. So it's 6 plus 10, which is
16.
16. So I'm going to add that to whatever the 4 arc lengths add up together.
Sounds
okay?
good.
Now, since they're all congruent, I could find one and then just multiply it by 4, right?
Yeah,
Now,
definitely.
the thing is they're not semicircles.
No.
So it's not like we can put them together and form a circle.
Right.
So let's approach it with finding one and then multiplying by 4.
I think that sounds like a great approach.
Now, I love what Ms. Hochraby said about the measure. This is probably can be the most missed question because they see this 150 degrees and they're like, oh, 150 degrees is the arc measure. But if you kind of extend out, not the best picture, 150 degrees is this angle, which is the measure of this arc. We want to find the length of this arc.
Right.
So we would need to know the measure of this arc, which means I need to know this angle measure.
Right.
So how would I find that?
Well, I'm going to want to take 360 degrees, the whole thing, minus the 150, which would give you our 210.
So that would be the arc measure.
And I also, just by looking at that, don't ever go by the picture, but if you notice, 150, that's less than 180 degrees. That'd be less than straight across. And this is definitely, this arc, the central angle that they're giving you here is more than 180
Exactly.
degrees. So just some things to be careful
Okay, so we know that arc length, that's what we're trying to find. I'm just going to call this x. Arc length is always compared to the circumference. So you do 2 pi r, and the radius is 2 on all of them, equals the arc measure, which we found was
210
over
360.
Okay, so I can go ahead and simplify this x over 4 pi. And I know some of you do the circumference off to the side, doesn't matter. You could simplify this down, or we can leave it. What do you want to do?
It doesn't matter. If we simplify it, we get 7/12. It's not very pretty. I would assume most people would probably, you could even just do the 21 over 36 if it helps with that too. Whatever is easiest for you guys.
I'm just going to do, since you said it, I'm just going to keep it like that. So cross multiply, so it'd be
12x, yep.
Oops, equals 28 pi.
28 pi.
All right.
We'll leave it exact.
And then divide by 12. Now, I know 12 and 28 don't divide nicely, but we can simplify.
Can I call it just like maybe 2 1/3?
Or, I like mixed
Or
number.
should we leave it
improper.
improper?
Let's leave it improper.
Okay, sounds good. So that should give us, let's see,
8 pi over 3.
Yeah, 8 pi over 3.
Okay, because 4 goes into, or is it, wait, let's see.
No.
4 goes into that. 4 goes into that. That would be
7 pi over
7 pi.
Uh-huh.
I meant that.
Well, that's what originally I was saying. I'm like, wait, yeah. Okay,
So
7 pi.
7 pi
Over
over
3.
3. And again, 4 goes into both of them.
Right.
Okay, so that's just this one. We have how many of those?
We have 4 of them.
Okay, so what am I going to do with that?
So I probably want to take my 7/3 pi, or 7 pi over 3 times 4.
And the thing to do this, if we want to leave it in exact form, you're just going to do top times top. So it would be...
A 28 pi over 3.
And can't simplify
And
that
that
anymore.
doesn't simplify anymore.
So we're just adding that to 16.
Okay.
Okay.
Now, those aren't like terms either. So really, the exact form is just that.
And again, guys, it doesn't give you units. Okay, so leaving it exact, and again, guys, if you leave it in exact form, all right, you need to make sure that you're careful with those fraction ideas.
Yeah.